Hey everyone, let's take a look at some of the basics of our project, particularly how to enter some data into Desmos. First what we want to do is in My Classes, go to Files, Blank Notes, Student Debt Part 1, scroll down till you get to Lecture 5, and then go to page 2, right? Then you're going to click on this page right here, right? And it should get you want to choose the Excel data. It should give you something like this. Okay. Then you want to go to table CP2, and this will give us the prices for tuition and fees in $2020. There we go. And we're interested in finding those tuition and fees in $2020 for four-year colleges, nonprofit that is, public four-year colleges, and public two-year colleges, right? Private, public, and public 2 years. We're going to do it from 1990 to 1991, and we're going to go all the way down until we hit 2020 to 2021. Okay? Note that there is a second column down here. Don't do that. Do this, okay? This is pricing in 2020 dollars, right? This is like, if it were today, if we were paying today, this is how much we'd be paying, okay? So this is effectively adjusted for inflation, okay? So what you want to do now is open up Desmos. If you haven't created an account, then please do so, right? Desmos.com if you're on a computer, or you can download the Desmos app. Go down to Statistics, Linear Regression, okay? And we're going to use this chart, but we're going to expand on it a little bit, okay? We're entering 31 data points, so you want to go ahead and just enter points like this. Oh, look, this is very nice. It seems to figure out what I want to do, and it just let me do that. Each of these in the x-axis right here is a time period. Each of those x-coordinates is a time period. It represents 1 year, right? So 1 represents 1990 to 1991, 2 represents 91 to 92, etc. The y, right, the y-axis, or the y components of the point, I should say, the y-axis is going to represent tuition price. So for year 1, I see that tuition is $18,560. So that's what I'm going to enter in here. Okay, and I'm going to press the down key, not the enter key, right, so that I don't have a blank space. That would be annoying. Then I'm just going to keep doing this, right? 18,660, 19,270, etc. You just keep doing this, right? 19,760, 2460, right? So this might take a few minutes to do, okay? 2760, etc. You keep doing this, okay? And what you wind up getting is a set of points. I'm just going to cut to my other graph where I've done some of this out. Let's get rid of this guy. Okay. And we're going to get all 31 data points. Okay. Let me actually turn this off real quick. Turn this off. Okay. And this is what we get. Okay. From this data point. It might condense it and say 20 more rows, show all, whatever. That's fine. These are the data points. This is the prices. Let me delete these. These are nonsense. These are all the prices for each year of tuition and fees for private four-year universities. Okay? And they're plotted very nicely on this axis right here. If you don't see them, then you need to go to the wrench right here. Go to the x-axis. Look, your values are between 1 and 31, right? So maybe make it between, -5 and, 35, right? So that gives us a good X range. For Y, well, look, the lowest price is 18,500, so maybe put it 17,000. And the highest price was about 38,000, so maybe put it at 40,000. Okay. And then press enter, and look, you're given this nice little plot right here. If you ever need to see more of the graph, you can always do that, but, it's kind of nice. Perhaps if you want to just copy the image, but we want to have our data points right here, okay? Now, here's the thing. We want to identify a trend with this price, okay? So what we do is Desmos has this nice little thing right here. Let me delete these guys right here. We can press Y1. By the way I got that subscript was I did shift minus sign. Then I want to press the right arrow key to get out of the subscript. And instead of equals, I want to do tilde. That's shift and then the top right corner of your screen next to the 1 key. And I'm going to do call it maybe M1, X1, that's important, plus B1. Okay. I'm not sure I needed the subscripts for M and B, but it just may as well, right? So what this says is that, look, there appears to be a nice linear trend, right? This is the best fit line to the points. Okay? If I wanted to instead consider a quadratic regression curve, right, that's the shape of a parabola, I would do, actually I would do y1 tilde, and then it would be a1 x squared plus, a1 x1 squared plus, I don't know if I want to call this B1. I'll call this D1 X1 plus C1. Okay, this gives us, let me get rid of the line for a sec here. Right, you can tap the icon to get rid of the shape. That might look like a line, but actually you can see it's part of a bigger parabola. Right? It looks pretty similar to the line. It takes a little while for them to diverge, but it is a different shape, right? And the goal of this, right, is to see, what's the best way to predict college pricing, right? You could go out even another degree if you wanted. Y1 is similar to, and we could say this would be, maybe I'll call this I guess I'll try calling this A1. Maybe I don't even need it. I'm just going to call this A, AX1 squared. No, sorry, not squared. Cubed plus B X1 squared plus C X1 plus D. Right? I just called it A, B, and C there. Right? And so here, this actually gives a cubic function, right? You can see that the function's a bit different. Now, long term, you can see it behaves a little bit differently, right? But short term, it seems to be a little bit normal, right? So you could even go up to a degree 4 polynomial. I'll let you figure that one out. But maybe from each of these curves, try to figure out which one you think is best. I'm totally fine with your just considering the linear relationship. That's definitely what's most commonly used. I think that's what most people in class want to do. Okay, then what you want to do is you want to look at a couple of things. In particular, note that for this this one right here, the linear one, for example, r squared is 0.997 basically, right? If we round it up, it'd actually be 1. That means that it's extremely close to the points. This line gives a very good fit to the points. And so it appears to be quite predictive. Okay? Also want you to note the parameters M1 equals blah, B1 equals blah, right? 679 point whatever, 17,000. That means that the line has equation y equals 679.616 x plus 17,106.3. So that's the regression, that's the linear regression equation that you're using, okay? Now what I'd like you to do, and I'm not going to do this in the video, but I want you to do the same thing, or maybe I'll do the first couple, for public four-year universities. Again, starting in 1990, see how this is public four-year universities. Right? Starting again in 1990 to 1991, so I think that's $3,800. Remember, press down instead of enter. And then it goes up to, right, etc. So you keep doing that all the way down, and you see you're getting your points. And they're down here because they're in the thousands, not tens of thousands. But if you do this, then you should get 31. I don't know why this is 30.8. That's weird. It should be 31. Weird. You should get 31 values. And you might guess they're in a similar sort of trend. They're in an increasing trend. When you get all of those, you're going to do the exact same thing, except you're going to do y2. Or if you wanted to consider the quadratic, then it's going to be y2. Now, again, yours is going to look quite different from mine because I entered only in 2 points, right? All right. Let's get that. Right, the more points you enter, 410, 4300, the more that these shapes will change. Right? So just keep that in mind. You're going to do it for that too, and then I'll let you figure out, let's call this one, I don't know if you can see that, but I called it Y3. One last set of points here. This is going to be the price of public 2-year universities, right? Again, we're starting 1990 to 1991, so we're talking about 1810. The next one is 2230, etc. Okay. Whoop, that said Y3 for some weird reason. That's what I And again, if you want to fit your line to that, then you can make it Y3 equals. Now, really what you should do is you should have a separate curve for all of these, right? So maybe you have a Y1 equals that. You have Y2 equals, mx1 plus b. And then you have y3, what is, mx1 plus b, for example. x1 plus b, right? So again, this is just partially completed. You need to fill in the rest of these. And then what I want you to do is I want you to answer all of these questions, right? So if you go over here, right, graph the tuition and fees, right, fit the data to a polynomial function, that can include linear. And then answer these questions. Please type it all up. For questions 1 and 2, please put the graphs, please take a picture of the graphs there. Whoop. I don't know why I seem to have lost that one. That was weird. But, just get it back out here, right? Please, screenshot the graphs if you can. I guess be a little careful about going between things. Make sure to save. I just lost some of the data. But answer these questions, type them up, and submit them, okay? So that's what you do. That's a little basics on the project. Remember, complete sentences, please. All right, that's all.